Good morning, friends. So today we are going to start parabola. Before discussing what parabola is, let us first revise the definition of conic. So what is a conic? So it is locus of a point such that ratio of its distance from a fixed point we call fixed point as focus and a fixed line which is called directrix is constant. Okay, and this constant is called eccentricity. This is the definition of conic. So under conic, depending upon the variable, depending upon this constant, we would have circle, parabola, ellipse and hyperbola. So as far as parabola is concerned, let us see the definition of parabola. So parabola is defined as locus of a point such that ratio of its distance from a fixed point, which is focus, and a fixed line, which is directrix, is same. Okay, so in this case, if the point P traces a path such that its distance from a fixed point and a fixed line is same, then the path traced by the point will be called as parabola. Okay, so let us write the definition. So it is locus of a point P distance of which is same from a fixed point which is focus and fixed line which is directrix is called parabola. Okay. Okay, so this is the definition of parabola. So let us suppose this is a fixed line L, this is the fixed point S. Okay, so the fixed line is directrix and the fixed point is focus. There is a point P which traces a path such that distance of point P from the directrix, which is PM, okay, and distance of point P from the fixed point S is always same. So PS upon PM is equal to 1 in case of parabola. So as long as P satisfies this particular condition, path traveled by point P would be lying on parabola. Okay, you must note one particular thing about this, that midpoint of this particular line will also lie on parabola. Now, why is that? So, the definition of parabola is PS upon PM is equal to 1. So, PS should be equal to PM. If point P comes in this position, then PM will be equal to PS. Hence, this will be midpoint of this particular line. So, by diagram, we can say that this point lies on parabola. Okay. So, as long as PS is equal to PM, point P is going to lie on parabola. Okay. Now we are going to discuss some terminologies of parabola. Okay, so the first is axis of parabola. So the axis of parabola is line which passes through focus and it is perpendicular to directrix. So if this is directrix and this is focal, so this line which is perpendicular to directrix and passing through focus is called its axis. Line perpendicular to directrix and passing through focus. Okay, the second is focal chord. Okay, so if this is the path traced by point P, this is parabola. Okay, so any chord of the parabola, as the name suggests, okay, according to the name we can predict its definition. So as the name suggests, any chord of the parabola which passes through focus is a focal chord. Chord passing through focus. Okay. The next would be vertex. So vertex is point of intersection of parabola with its axis. So if this is the parabola and this is the axis of parabola, this will be its vertex. Fine. Now the next one is ordinate. Or rather double ordinate. So double ordinate is the chord of parabola which is perpendicular to its axis. Okay. Okay, any chord which is perpendicular to the parabola, perpendicular to the axis of the parabola is called its axis. Double ordinate. Okay, so the last term that we are going to see is latus rectum. So latus rectum is double ordinate passing through focus, which means this one. So if it is double ordinate, it should be perpendicular to axis, okay? And since it passes through focus, it is a focal chord as well. So this is the latus rectum of the parabola, okay? Or you can say a focal chord perpendicular to its axis, okay? Focal chord perpendicular to its axis. Okay, so these are the terms that we need to remember. So in our diagram, this is axis, this is directrix, this is focus, this is focal chord, and this blue line is latus rectum. Okay. Now let us derive the equation of parabola. Okay, so in order to derive the equation of parabola, first we are going to see what a standard parabola looks like. Okay. So for standard parabola, if this is the directrix, this is the focus. As we have already discussed, midpoint of this particular line segment will lie on parabola, right? So if this is a, let's call it A. Okay, so A will definitely lie on parabola. So for standard parabola, we take A as origin, and if we take A as origin and we take axis of parabola as x-axis. Okay, so see, if this is origin and this horizontal line passing through A is x-axis, so this is the case, this is our parabola, this is focus S, and if this is origin, this will be our y-axis. Okay, let us suppose the coordinates of point S are a comma 0. If this distance is a, this distance is going to be minus a, and hence the equation of directrix will be x is equal to minus a. Okay, so the equation of directrix will be x is equal to minus a. The coordinates of focus will be a comma 0. In this case, the coordinates of our vertices will be 0 comma 0. Okay, so these are 0 comma 0. So in order to derive the equation of a parabola, let us first assume a general point x comma y on parabola. Okay, so if this is x comma y, so according to definition of parabola, these two distances should be same. Okay, PS should be equal to PM. Okay, now from diagram we can see that this distance is equal to x, this distance is x, and this distance is a. So PM is equal to x plus a. PM. Okay, so PM we have already calculated from the diagram. This distance is x, distance of this point from y-axis, which is x, plus this distance is a. So it is x plus a. And as far as PS is concerned, we can use the distance formula between P and S. So it would be x minus a whole square plus y square. Okay. Now let us simplify this equation. Squaring both sides, we get x minus a whole square plus y square is equal to x plus a whole square. Okay. So it is x square minus 2ax plus y square plus a square is equal to, so x square and a square are going to cancel each other. We get y square equal to 4ax. So this is the equation of parabola that we obtained. Okay, so this is equation of standard parabola. axis of which is x-axis, and vertex lies on vertex is origin and focus is a comma 0. Okay, we need to remember this equation. Y square equal to 4ax is the simplest and most commonly used equation of parabola. Okay, next we are going to calculate length of latest rectum. Okay, remember the equation. I'm going to write it down over here. So y square equal to 4ax is the equation of this parabola. So in order to calculate length of latest rectum, let us first draw the latest rectum in the diagram. So as we have seen, latest rectum is a chord passing through focus and perpendicular to the axis of parabola. Okay. So in order to calculate this distance, let us find these coordinates. So at this particular line, x coordinate is a. Now how can we find y coordinate? If we are able to find y coordinates of these 2 points, we would be able to calculate the length of latest rectum. So we already have the equation of parabola, okay, and we know the x coordinate of these 2 points. So if we know the x coordinate of these 2 points, which are both x is equal to a, so putting x is equal to a in this equation, we get y square equal to 4a square, or y is equal to plus minus 2a. Okay, so since x coordinate is a and y coordinates are plus minus 2a. Okay, so the points a and b will be, point a will be 2a comma a, sorry, a comma 2a, and point b will be a comma minus 2a. And clearly the length of latest rectum will be the length of AB, which is length of latest rectum is equal to distance between these 2 points, which is 4a. Okay, we need to remember this result, which is length of latest rectum of a parabola is 4a. Okay. Now I am going to draw a diagram which will help you to deal with any random parabola for which, if the case is not where the vertex is origin and the axis is not x-axis. Okay. So in any parabola, if you shift this parabola or rotate this parabola, lengths are going to remain same. Okay, so if this is the directrix, this is the parabola, and this is, suppose, latest rectum. So what you need to remember is this distance, this distance, this distance, and this distance. So this is latest rectum, which is perpendicular to the axis of the parabola. Okay. Now, if we are rotating this parabola and trying to generalize it, this distance is a. Let's write it as a. Distance between vertex and focus will be a. So this is vertex and this is focus. This will be a. Okay. Distance between focus and the extremity and each of the extremities of latest rectum will be 2a. This distance is 2a and this distance is 2a. So if this is a, this is a, this is 2a and this is 2a. We need to remember this. Okay? You just need to deal in terms of distances when the parabola is not at origin and its axis is anything other than x-axis. Okay? We are going to see similar cases when the axis of the parabola is y-axis. Okay? But this is the most general case that would help us in dealing with parabolas for which origin is not the vertex and its axis is not along x-axis. Okay? So now, let us try and solve a few questions. So question 1. Find length of latest rectum, focus, directrix, of parabola y square equal to 16x. Okay. So we have already seen y square equal to 4ax. Compare it with y square equal to 16x. Okay, so a is equal to 4. When we have the value of a, we can always write the equation of directrix, coordinates of focus and the length of latest rectum. So focus is a comma 0, which becomes 4 comma 0 in our case. Directrix is x is equal to minus a, which is x is equal to minus 4 in this particular question. Length of latest rectum is 4a, which is 16. So please note that the coefficient of x over here is the length of latest rectum. Okay. For this to be called as length of latest rectum, the equation of parabola should be in this format only. Okay. If you are looking at an equation something like that, root 2y square is equal to 7x. That does not mean 7 is the length of latest rectum. Okay. The correct form that we want the equation to be in is this one. Now, this is in our desired form, and now you can say that 7 by root 2 is the length of latest rectum. Okay, so do not make that mistake. So let us have a look at another example. Find vertex, focus, length of latest rectum, directrix of parabola y square 4y square plus 12x minus 20y plus 67 is equal to 0. Okay. So this is not the parabola we have studied. Okay, let us first simplify this a little bit. So club the terms of y together, we get 4y square minus 5y. Okay, so keep it to, just to keep it simple and calculations. We are as of now focusing on understanding of concepts. So this would be 10 plus 12x plus 67 is equal to 0. Okay, now let us complete the whole square for this. So y square minus 10y plus 5 plus 25. So since we have added 50 over here, we need to subtract 50 plus this would be 17 is equal to 0. Okay. Let us complete the whole square for this. One more change in this question before we study another type of parabolas. Okay. So the equation becomes twice of y minus 5 whole square is equal to 12 times x minus 17 by 12, which is y minus 5 whole square is equal to 6 times x minus 17 by 12. So now if we suppose this particular thing as capital Y and this particular thing as capital X, so this is the equation of parabola which we have already seen. Okay, so everything that was going to happen at 0, 0 is now going to happen at 17 by 12, 5. Okay, so now here comparing it with the original parabola, we can see that the length of later sectum is 6. So 4a is equal to 6, a is equal to 3 by 2. Vertex is clearly 17 by 12, 5. Okay. So vertex will be 17 by 12, 5. So this is our vertex. Parabola will be this way. Okay. So we have already calculated length of later sectum. Now what do we require else? So vertex we have already seen at 17 by 12, 5. What's next? Focus. So focus is at a distance a from the vertex. Okay, so this is 17 by 12, 5. So A is 3 by 2. So a point at a distance of 3 by 2 in this direction will be 17 by 12 plus 3 by 2, 5. Okay, so it will be 17 by 12 plus 3 by 2, 5. Okay, now when we simplify this, we get 35 by 12, 5. So this is our focus. So in this we have used a diagram which only dealt with distances. So we know that distance between focus and vertex is a. We already know the value of a, hence we can find focus with the help of vertex. Okay, what else do we need to calculate? We need to calculate directrix. Okay, so directrix. So for directrix, what we need to do is we need to go at a distance of 3 by 2 from this particular point. So equation of directrix would be x is equal to 17 by 12 minus 3 by 2. Okay, which will be minus 1 by 18. Okay, so we have already calculated everything required in this question, and we have seen how easy it becomes when you deal everything in terms of distances rather than coordinates. Okay, if you would have shifted this particular parabola to this particular equation, then you would have to find all the parameters for this equation and then shift them back to this particular system. Okay, indirectly it doesn't matter because you have also used shifting of origin over here, but in a simpler way. Okay, so this is later sectum, this is directrix, focus we have found, and just in case if length of later sectum is asked, you can stop your question right here. Okay, because here with the coefficient you can directly say that length of later sectum is 6. Okay. Now we are going to see some more parabolas, standard ones. So we have seen y square equal to 4x. Y square equal to minus 4x. Okay. X square equal to 4ay and x square equal to minus 4ay. Using the symmetry of parabola, we can see that there is not much change among these four equations. Okay, let us trace the graph and see how parabola looks like. This parabola we already studied. So here this focus is a comma 0, its extremities are a comma 2a, a comma minus 2a, and its directrix is x is equal to minus a. Okay, let us now first look at this particular parabola. So minus suggests that the parabola is going to open towards left. Okay. So this was the parabola which was opening towards right. Since there is a negative sign, we understand that the parabola is going to open towards left. Okay. Here the focus was a comma 0, so here the focus will be minus a comma 0. Okay. The directrix here was x is equal to minus a, it will become x is equal to a in this case. The extremities of later sectum will be minus a comma 2a and minus a comma minus 2a. Okay, so if there is a minus sign, just take the image of the parabola with respect to y-axis. Okay. Now coming to this particular parabola, its x square is equal to 4ay. Okay. So we can see that here the axis of the parabola was x-axis. So clearly, since x and y are interchanged, the axis of the parabola will be y-axis, and with the positive sign we can understand that the parabola would be opening towards positive y-axis. Okay. So if this is parabola, we know that distance of focus from vertex will be a. So this point will be our focus, and its coordinates will be 0 comma a instead of a comma 0, since this lies on y-axis. And these two distances are 2a and 2a. This point at a distance of 2a will be 2a comma a, and this distance will be minus 2a comma a. Okay, and now the equation of directrix in this case will be y is equal to minus a. Okay, now if these three graphs are clear, this will be very easy. It would be downward opening graph with its focus as minus a comma 0 and coordinates of latest rectum as extremities of latest rectum will be, sorry, it will be 0 comma minus a, 2a comma minus a and minus 2a comma minus a. The equation of the directrix in this case will be y is equal to a. Fine. So these are the four parabolas that we need to remember. Once you are clear with the basic concepts of this, if you have the conceptual understanding of this particular parabola, it wouldn't be much difficult to remember these three. Okay? Now, next we are going to study parametric equation of a parabola. So we are going to derive each and everything as per our standard parabola, which is y square equal to 4x. So if this is our parabola, okay, its parametric form can be given as x is equal to 80 square and y is equal to 280. You can see that when x is 80 square, y square will be equal to 4a square t square, and then y will be equal to 280. So for any variable t, whatever the value of t be, this particular point 80 square comma 280 will always lie on parabola. Okay, because this particular point 80 square comma 280 always satisfies this equation. Okay, so this is the parametric form of this parabola, okay, where our parameter is t. Okay, so the parametric form of the parabola makes our questions very easy. Okay, let us understand this with the help of a couple of examples. So what we have learnt is this point is 80 square comma 280. Okay, where t is our parameter. Okay, so let us discuss one question. An equilateral triangle is inscribed in parabola y square equal to 4ax with one vertex at origin. Okay. So one vertex of equilateral triangle lies on origin. So according to the equation, we can see that the vertex of parabola is also one vertex of the equilateral triangle. Okay. Find the length of its side. Okay. So we have studied parabola up till its equations. We must have realized that a parabola is symmetric with respect to its axis. Okay. So if the parabola is symmetric with respect to its axis, equilateral triangle can be formed in a very symmetric way such that this line is bisector of this angle, and if this is equilateral triangle, this side, these three sides will be equal. This side will be equal to this side, will be equal to this side. And if there is a symmetry with respect to parabola, this angle will be equal to this angle. And in an equilateral triangle, we know that each angle is 60 degrees. So this angle will be 30 degree and this angle will also be 30 degrees. Now, this point is 0, 0. Let us suppose this point to be 80 square, 280, because that's the simplest form of the point on this particular parabola. Now, the slope of this line will be tan 30, and we can also calculate the slope of this line using two-point form. So, the slope will be 280 minus 0 upon 80 square minus 0, which should be equal to tan 30 degrees. So from here, a and a gets cancelled, is equal to 1 by root 3. So t is equal to 2 root 3. So when t is equal to 2 root 3, we can easily calculate the distance between these 2 points. Okay, so the distance will be, first calculate the point A. Okay, so the point A will be 12a, comma 8t square, comma 280, 4 root 3. So this will be the point A, and hence, since we know the coordinates of point A and origin, we can calculate its distance as OA is equal to 12a square plus 4 root 3a square under the root. So this is a square root of okay. So this is how we can calculate the distance. So you can see that how easy it becomes